Okay, here we are looking at Math 7 notes for 10-1. This is our last unit, EAS. And Unit 10 begins solving equations with variables on both sides. So we need to remember back from our Unit 4, back in December, that the goal of equation solving is to isolate the variable. Remember I told you I was going to ask you that a billion times this year? Well, it's about to be happening more. So isolating the variable, not variables, sorry, tells you that you want that x equals to be by itself. It won't always be x, could be y, could be any variable. We do this, we isolate the variable by using those inverse operations. Right, if x is being added to 4, the inverse of adding is to subtract, so we're going to, go through that. Where do we draw the line down the center? Just review things. That happens at the equal sign, right? Because that is splitting it into 2 equal parts. That is still going to be true. We're still going to be splitting that into 2 equal parts. And the reason that we're splitting it into 2 equal parts is so that hopefully you are more likely to remember to do the same inverse operation, that same operation to both sides. Right, if you have your equivalent equal sign and you add 4 to one side but not to the other side, you are no longer equivalent, therefore causing things to be wrong. Okay, so let's take a look. We have an old review example versus a new type of example. So first off, just taking a look at those, noticing the difference. You'll notice in our old example, we only have one variable, and it's on that left side of the equation. Whereas in the new example here, we have multiple g's, but they're on different sides of the equal sign. That makes a difference. All right, so starting with our old review example. What is preventing my x from being alone? That would be the 2 and the plus 3. I have to deal with the plus 3 first. The opposite of a plus 3 is minus 3. Positive 3 and negative 3 cancel out. 2x carries down. This is where you're probably using your calculator to at least check yourself. Negative 5 minus 3 is a negative 8. Last but not least, x is being multiplied by 2, so the inverse of multiplication is dividing. So I'm going to divide both sides by 2 to get that to turn into a 1. Negative 8 divided by 2 is negative 4. So x equals negative 4. Hopefully that was not too brand new for you. Now looking at our new example here, this is where things are going to get a little different. So now, we cannot possibly isolate the variable if we have the variable in 2 different places. We can't get something by itself if we have multiple places of it. So we're going to start by trying to move that 3g to the other side with the other g's. Now, this 3g is a positive 3g, so to move a positive 3g over, I would have to subtract it or minus that 3g over. Notice here, I'm still canceling things out. 3g minus 3g goes away. That turns into 0. Carry down my negative 12, turning into 9 minus 3 is 6g. And now that we took that one little step and got our variables to be all on the same side of the equal sign, we now have a regular equation that we're used to solving. G is being prevented by this times 6, so we're going to do the opposite and divide by 6 to get G equals negative 2. If you are a human who does not enjoy negative signs, I would suggest that you pay attention to this. To avoid negatives, you always want to move the smaller variable. So that's why here I chose to move the 3g over instead of the 9g. It wouldn't be wrong to move the 9g, and I'm actually going to go off on a quick little sidebar real quick. You do not have to write this down. So just showing you a little sidebar. I would be getting the same answer if I had moved the 9g over. Minus 9g, that's not the best g of my life. The only weird thing that happens here is 3 minus 9g is a negative 6g minus 12 equals, I'm not going to forget to do my line down the center there, but now 9g minus 9g turns into 0 over here. So that's just kind of weird. There's nothing wrong with having 0 over there. I just have this extra step of needing to add the 12 to both sides. Or you could have added the 6g. That's not wrong either. And then dividing by the negative 6, leaving you with the same g equals negative 2. So same option, just a different way to do it. There's really no wrong ways to solve an equation as long as you're doing the same thing to both sides.